तो आज हम आगे कंटिन्यू करेंगे MCS-202 ब्लॉक 2 का यूनिट 7 और 8। 7 में है इनपुट आउटपुट ऑर्गेनाइजेशन एंड 8 में डिवाइस टेक्नोलॉजी। ये दोनों को आज ख़त्म करेंगे पढ़ के। तो स्टार्ट करते हैं। व्हाट आर इनपुट आउटपुट डिवाइसेस? IO devices are part of computer system that help to it communicate with the outside world like human or other machines connected to the computer. Main part of a microcomputer system, microprocessor or CPU, central processing unit, the brain of the computer that processes information. Memory includes RAM, which is temporary memory, and ROM, which is permanent memory. IO interface connects the computer to input or output device. So the main part of a microcomputer system, microprocessor, memory, IO interface. Microprocessor, the brain of the computer that processes information, or memory includes RAM or ROM. IO interface connects the computer to input or output devices. These parts are connected through buses, special pathway that carry data and control signals. Type of buses: control bus, address bus, data bus. Control bus sends control signal to manage action. Address bus sends information where to store, and data bus carries actual data and instruction. IO subsystem: the IO subsystem includes all the interfaces and devices for input and output. Its main job is to make communication between the computer and outside world fast and efficient. IO subsystems includes all the interface and device for input and output. Its main job is to make communication between the computer and outside world fast and efficient. What does an IO interface do? Connects external device like keyboard, display, printer to the computer. Send and receive control signals, status information and data between the computer and devices. Also help transfer instruction and data inside the computer between the CPU, memory and register. External devices: these are devices connected to the computer from outside. They can be grouped by how they communicate. Human readable devices provide information human can understand. Example: display, monitor, printer. Machine relatable devices store or read data in a way computer understand. Example: magnetic disk, CD, RW. Communication devices help computers send data to other device or network. Example: modem, used for internet communication. Real life example: human readable: when you type on a keyboard and watch a movie on a screen, you are using human readable devices. Machine readable: when you save files on a hard disk or USB drive, you use machine readable devices. Communication device: when you connect to the internet via a modem or Wi-Fi router, you use communication devices. So human readable, machine readable and communication devices. Machine readables: when you save files on a hard disk or USB, you use machine related device. When you connect to the internet via modem or Wi-Fi router, you using communication devices. What is an IO interface? It's a hardware bridge between CPU, memory and external device. IO interface is a hardware bridge between the CPU, memory and external devices like keyboard, printer. What is it needed? Because the processors are very different, CPU is an electronic and very fast. Peripherals are slower and electromagnetic. CPU use word size data. And peripherals use bytes and blocks. Each device works differently and needs special handling. Devices must not interfere with each other. What does the IO interface do? Control and synchronize data transfer between CPU and devices. Matches the speed different using buffer. Translate data formats. Detects error during transfer. Manage device operations safely. Simple example: It is like a translator and traffic controller, making sure that fast CPU and slow devices work together smoothly without conflict. Simple explanation for each. Communication with processor. What it does: moves data, control signals like command to read and write, and addresses between the CPU and IO device through system buses. Real life example. Imagine you ask a waiter CPU to bring a menu data. You give the waiter your table number, address, and instruction, like bringing the drinks list. Control signal: the waiter communicate between you, CPU, and the kitchen IO interface. IO devices through system buses. रियल लाइफ एग्जाम्पल इमेजिन यूज तो हो गया द किचन. ठीक है. सिंक्रोनाइजेशन. what it does: makes your data flows at the right time between the CPU and slower device by coordinating control and timing signal. Real life example: think of a traffic light controlling car at an instruction. The light IO interface control when cars can move so that everything flows smoothly without crashes, especially since some car goes slower than other. Communication with IO. What it does: sends and receives data, commands, and status signals between the interface and devices. Real life example: when you print a document, your computer sends the print command to the printer. The printer can send back a status like out of paper or printing done, so your computer knows what is happening. Data buffering. What it does: temporarily holds data because IO devices are slower than the CPU, preventing the CPU from waiting. Real life example: think of a delivery truck CPU dropping out package to small soap. The soap uses a storage room to hold packages until it can unpack them. The truck doesn't have to wait outside while the soap unpack. Error detection. What it does: check for error in data transfer or device problem and inform the processor to fix them. Real life example: when you send a text message, the phone checks if the message was delivered correctly. Not send a notification like message not sent, so you can if not, it sends you like message not sent, so you can try again. What is system bus? The system bus connects the processor, CPU to memory and IO devices. It is made up of three parts. Address bus send the address to the device and memory location. Control bus send control signal and command. Data bus transfer the actual data. How does communication happen? The processor sends the address to the target peripherals device using the addresses bus. Each IO interface has an address decoder that checks if the addresses match its device. If it matches, the interface activates its device. If not, the device stays inactive. Along with the address, a control command is sent via control bus to tell the device what to do. 4 types of IO commands sent by the processor. Control command: tell the device what action to perform, like smart printing. Status: check the status of the device, busy, ready, or the error. Data output command: processor sends data to the device through the interface buffer, sending a file to printer. Data input command: processor requests data from the device, which is then placed in the interface buffer for the CPU to read. Real life example: think of a buses like a postal service. Address bus is the address on the letter. Control bus is the instruction on what to do with the letter: open, reply, ignore. Data bus is the content inside the letter. The post office IO interface checks the address and deliver the letter to the right recipient. Okay. What is device controller? A device controller is an electronic component that connects an IO device like printer, keyboard to the system bus of the computer. Device control is an electronic component that connects to IO like printer and device controller. Okay. What is it needed? Not all IO devices can directly talk to CPU through the system bus. Some devices need help to understand and follow the rule of communication between the CPU and themselves. So a device controller acts like a translator and manager between IO device like a printer and a system bus. How does it work? One end of the controller is connected to the IO device, the other end is connected to the system bus. It manages data transfer between the CPU and IO device. It controls the device and ensures data is sent received properly. Real life example: imagine you want to talk to someone who speaks a different language. You hire a translator, device controller. You CPU speak the translator. The translator understands and passes the message to the other person. The other person replies and the translator passes it to you. A device controller connects IO device to the system bus. It acts as an interface and help in communication and control of the device. It ensures smooth data flow between the processor and IO device. What is device controller again? Again, in a simple term, maybe a device controller is a small electronic board that helps the computer talk to input-output device like printer, scanner, keyboard, hard disk. It acts like a middleman between the CPU and these devices. Important points: one controller can control multiple devices, just like one remote can control a TV, DVD player, and speaker. One device controller can make several IO devices. It's a circuit board inside the computer. It is plugged into the system bus and it is also connected to the device through cables. Ports are when you connect devices. The ports on the back of your computer, like USB ports, are actually endpoints of the device controller cable. You plug your mouse, printer, or other device into these ports. Types of controller. Single port controller can handle only one device like TV remote for just a TV. Multi-port controller can handle many devices at once like universal remote. Communication type: with DMA, direct memory access, the controller talks directly to memory, skipping the CPU. This makes things faster. Without DMA, the controller has to go through the CPU to send or receive data. This is so slower. Benefit of device controller: multiple devices, one controller. Connect many IO devices using one controller. Easy upgrades: you can upgrade or change IO device without changing the whole computer setup. Mix and match devices: you can connect device from different brands and types like HP printer to Logitech a mouse. Okay. Real life example: imagine your computer is a brain, the device controller is the nervous system, and IO device are hands, eyes and ears. फिर से पढ़ते हैं इसको. Imagine your computer is brain, the device controller is nervous system, and IO device are hand, eyes, ears. The brain, CPU, give instruction to the nervous system controller, carries those instruction to the hand or eyes, which is IO device, and vice versa. What is a device driver? A device driver is a software that help your operating system like Windows, Linux talk to the hardware like printer, mouse and keyboard. Think of it like a translator. The computer speaks in one language and the device speaks another. The device driver translates between the two so they can understand each other. Real life example: you click print on your screen. Here's what happened. Your app sends a general request: print this file. Your device driver translates that into a small instruction the printer understand. Click if the printer is connected. Make sure there's paper. Move the print head. Print the characters. Without the drivers, the computer would not know how to talk to printer. Device controller in Windows. In Windows, drivers are usually DLL files, dynamic link libraries. These files contains reusable code and only one copy is needed in memory. Devices makers can create and add drivers without changing the Windows system itself. Plug and play. Windows has a cool feature called plug and play. This means you just plug in a device and Windows automatically finds and install the right drivers. No need to manually install the driver, it detects, install and configure it automatically. Device drivers in Unix and Linux. The Unix system devices are part of the operating system called the kernel. These drivers are connected as a object code, compiled machine code. If you want to add a new device like a webcam, you usually have to add the driver, rebuild the recompile the kernel. This method is a simple and fast, but it requires technical step kernel rebuilding, which can be hard for beginners. The dev directory in Linux system, every device is shown as a file in the dev folder. Dev SD hard disk, dev printer. So the summary table: driver format, DDL, dynamic link library, and the Unix kernel object code. Driver installation, plug and play, manual kernel relinking. Flexibility, easy to add, remove drivers, less flexible, requires recompilation. And device location installed by system listed by dev directory. Asynchronous data transfer. Asynchronous data transfer, async transfer. In a digital computer system, data must be transferred from one unit to another. For example, from the CPU to the I/O interface. To make this transfer happen properly, there must be some coordination and synchronization between both sides. In a digital computer system, data must be transferred from one unit to another, for example, from the CPU to the I/O interface. To make this transfer happen properly, there must be some coordination or synchronization between both sides. Two main modes of data transfer: synchronous data transfer and asynchronous data transfer. The CPU and I/O interface share a common clock, some timing signal. That means both units know exactly when to send or receive data. Example, like two people clapping hands together at the same time using the same rhythm. And asynchronous data, the CPU and I/O interface have their own separate clock, timing is different. They don't follow the same rhythm, they work independently. So they need some extra coordination to know when to send or receive data. Problem in asynchronous mode: because there is no fixed clock or timing, it's hard to tell whether the data sent arrive or it's old data already read. So we need special method to manage these. Two solutions to fix the problem: stop control method. A stop signal is used. One unit sends to stop signal to indicate, hey, I am sending data now, I am ready to receive data. The receiving unit watches for the stop and reads data only when it sees the signal. Handshaking method, this is more reliable method. It uses two signals, one from sender and one from receiver. Handshaking method. This is a more reliable method. It uses two signals, one from sender and one from receiver. This method is just like two people shaking hands before giving or receiving something. Both sides agrees and respond. Real life example: imagine sending a package synchronous. You both have watches and meet at 5 p.m. sharp to exchange. Asynchronous: you don't have the same watch, so you call each other to confirm the delivery and pickup time. Input-output techniques. Programmed I/O. What is it? In programmed I/O, the CPU itself controls everything related to input-output operation. It starts, watches, and ends the process like manager who does all the work by themselves without delegation. How it works? CPU give command. The processor send a read-write command to I/O interface. Request is made. The CPU tells the I/O interface that it wants to do an I/O operation. I/O interface sends a status. The I/O device sets status. I am ready or I am busy. CPU keeps checking the status, pulling. The processor keep asking, are you ready now? Still not ready. CPU waits until the I/O device is ready. Finally, data is transferred from CPU to I/O device or from I/O device to the main memory. This waiting is called polling. Polling means the CPU repeatedly checks if the I/O device is ready. This wastes time because the CPU just waits instead doing other useful work. Disadvantages: the CPU wastes a lot time wasting for the slower I/O device. It can do many other tasks while checking the I/O status. So, if not sufficient, especially when dealing with slow device like keyboards, printer, etc. Real life example: imagine you are printing a document. Your CPU click prints, then you keep looking at the printer every second. It's printing yet now still not printing. Instead of doing other work, you just watch the printer. That's what programmed I/O is like. I/O command. Whether the CPU wants to talk to an I/O device like printer or keyboard, it sends the address of the device and I/O commands to tell what to do. There are 4 main I/O commands: control command, test command, read command, write command. So 4 main I/O command. Control command used to active the device and tell it what to do. Example: a use command is to make a device ready for reading or writing, like switching on a printer and selecting it before printing. Test command used to check the status of the device. It is ready, then ready, busy, or in error, like checking if the printer has proper or if there is an error. Read command used to get data from the I/O device to the CPU. Reading type keys from a keyboard into the computer. Write command used to send data from the CPU to the I/O device. Example: sending text from the CPU to the printer to print. Interrupt driven I/O. Simple explanation: in program I/O, the CPU keeps waiting and checking if the I/O device is ready. This wastes the CPU's time. To solve this, we use interrupt driven I/O, where the CPU doesn't wait, it keeps doing other tasks. How it works: CPU gives read and write command to the I/O interface. CPU goes on to the other work. I/O device work in the background. When the I/O device is ready, it sends an interrupt signal to the CPU. After each instruction, the CPU checks if an interrupt has come. If yes, it pauses current work and saves its progress. CPU asks for the I/O data. I/O interface sends the data. CPU goes back and continues still earlier task. Advantages: CPU does not waste time waiting. It is only deals with the I/O when needed, save timing and increasing performance. Real life example: imagine you are writing a report. CPU works and waiting for someone to print the file. I/O task. In program I/O, you just sit and wait for the printer. In interrupt driven I/O, you keep writing your report and the person taps your shoulder when the printing is done. What is interrupt handling? An interrupt is like a signal sent to the CPU when something urgent happens, like an I/O device needing attention or an error. The CPU temporarily stops its current work, handles the urgent task, and then goes back to what it was doing earlier. What happens step by step? An IO device sends an interrupt signal to the CPU. The CPU finishes its current instruction. The CPU acknowledges the interrupt to the IO device. CPU saves the current context like its memory, register, program counter, PC, next instruction addresses, program status word, status the processor, also save other register. CPU jumps to a special program called the interrupt handle to handle the device. When done, the CPU restores the saved data from the stack. CPU returns to the previous task just like nothing happened. Real life example. Imagine you are cooking and suddenly your phone rings. You pause cooking, answer the phone, then resume call right when you left off. Key terms: interrupt handler, mini program to deal with the interrupt, stack, temporary storage area used to save CPU data, PC, program counter tells where to continue after the interrupt. Program status works tell the status to the CPU before the interrupt. So the final, what is DMA? Direct memory access. Important है क्या? DMA is a method that allows data to be transferred directly between IO device and memory without involving the CPU again and again. DMA is a method that allows data to be transferred directly from IO device and memory without involving CPU again and again. DMA allows data to be transferred directly between IO device and memory. Why do we need DMA? In programmed IO and interpret driven IO, CPU is involved in every data transfer between memory and IO, but CPU has to do many other tasks, so using it for a data transfer is a waste of CPU time. That is why we use DMA to save CPU time and make data transfer faster and more efficient. How data works? CPU tells DMA controller what operation to do, means read and write. Address to the IO device, starting addresses of memory block, number of word to transfer. After that, the CPU starts doing other work. It is now free. DMA controller takes over. It starts transferring data directly between IO device and memory. When the full data is transferred, the DMA sends an interrupt to the CPU to say I am done. CPU then continues its normal operation. Real life example. Imagine you are a manager, CPU, and you need to sift 100 books from the store. Imagine you are a manager, which is CPU, and you need to sift 100 books, means data, from the store, means IO device, to the library, memory. ठीक है? Without DMA, programmed IO. Without DMA, you, the manager, picks and move every book one by one. It's slow and waste of time. With DMA, you assign a worker to move the books. You only give him task, move books, where from, store, where to, library, how many, 100 books. Then you go to the other important task. When the worker is done, he tells you work is complete. This saves your time just like DMA saves the CPU time. Important terms to remember. DMA controller, a special hardware that handles data transfer between IO and memory. So important terms to be remembered is DMA controller, a special hardware that handles data transfer between IO and memory. Cycle stealing. DMA takes control of the system bus for one word transfer, then return it to the CPU. This causes a small delay, but it's worth it. Interrupt by DMA. At the end of transfer, DMA tells computer what an interrupt signal. The how can we write it in a exam kind of context? So DMA direct memory access. Remember the full form? Direct memory access. It is technique where data is transferred directly between IO device and main memory without the consultant involvement of CPU. In this method, CPU sets up the DMA controller by giving it Operation type, read and write, IO device address, memory starting address, number of words to transfer. After this, the DMA controller handles the entire data transfer. Once done, it instructs the CPU to inform that the job is complete. Advantages: save CPU time, faster data transfer, useful for large data blocks. This method is useful in systems where multiple programmers running, like where it is multi-programming. Example: just like a manager assign a worker to shift file between two rooms so that he can focus to another work, DMA works the same way by reducing CPU load. External computer interface: connect precursor device like printer, disk or keyboard to the IO interface of the computer. The two main types: serial interface and parallel interface. Transfer one bit at a time, transfer multiple bits at a time. Step communication includes sending control signal, getting acknowledgement, performing data transfer, receiving final acknowledgement. Based on connection type, there are point-to-point, one device per line, keyboard, printer. Multi-point, many devices share one line. These interfaces are essential for enabling external devices to communicate with the computer system efficiently. Okay, that is it in Unit 6. Continued with Unit 8. Unit 8 is all about IO technology. Okay, device technology. IO टेक्नोलॉजी इसमें क्या है? These are some points. Unit 8. Unit 8 seems easy. Easy सा लग रहा है ये. ओके, करते हैं. IO टेक्नोलॉजीज. So, in the previous unit, we learned about input-output interface and IO techniques like programmed IO, interpret-driven IO, direct memory access. These techniques help the computer communicate with external device. A computer supports many IO devices to transfer data between the computer and the outside world. This unit introduced some common IO devices such as mouse, keyboard, monitor, printer, scanner, video card, sound cards. It also talks about modern voice-based input device. The goal of that unit is to give a basic understanding of these devices, their characteristics, basic functions, how they relate to the processor. It does not cover all the details but focus on the essential information to help you understand how this device works with the computer. Right, to go with mouse. The mouse was first thought by the Douglas C. at Stanford Research Institute. The Xerox Corporation made the first actual mouse device, a device in a handheld input device that controls a cursor on the computer screen. A mouse is a handheld input device that controls a cursor on the computer screen. The mouse detects movement in two dimensions, left, right and up and down. Okay, so this is my cursor. So अभी मैं लैपटॉप में हूँ तो ये टच पैड के थ्रू हो रहा है. अदर देन दैट अगर मैं माउस लगाती तो ये कह सकते थे कि माउस से हो रहा है. जो लेफ्ट एंड राइट, अप एंड डाउन on a surface which is a screen. Usually a mouse has 2 or 3 buttons, but even one button is enough to control the cursor. Type of mice. There are many type like wired, wireless, Bluetooth, trackable, optical, laser, magic, and USB mice. Mouse resolution and pooling rate. CPI counts per inch is how many signals the mouse sends per inch moves. Typical CPI values range from 400 to 1600. Pooling rate is now how the mouse sends data to the computer measured in hertz and ranging from 16 hertz to 1000 hertz. Higher CPI means the cursor moves faster, but this can make it harder to control precisely because more data is sent required to the higher pooling rate. Classification of mice. Mice are classification mainly by connectors, how they connect to the computer. Bus mouse, old type, connected via special bus interface card inside the computer. Serial mouse, connected via serial port 9-pin connector, mostly outdated now. Okay, this is outdated. PS2 mouse, use a small round 6-pin connector. Green port is the mouse, purple for keyboard, still used in some computers. USB mouse, most common today, connected via USB port which is replaced PS2. Wireless mouse, no cable needed, uses batteries, offers better comfort and freedom of movement. Sensing technology, how the mouse detects movement. Mechanical mouse has a rolling rubber or metal ball underneath. As the ball rolls, sensor detects its movement and moves the cursor. Yes, correct. I have seen this kind of mouses back then in my school days. Optical mouse uses LED and sensor to detect movement by analyzing reflected light from the surface. Yes. Keyboard, what is it? And an input device used to enter letter, number, and special character into a computer. Keyboard layout, the arrangement of keys usually based on the typewriter layout. The common English layout is named after the sixth letter on the top row. Okay. QWERTY. This is the first 6 letter on top of the row in the keyboard. Yes, correct. IBM's popular keyboard has 101 keys including alphabets, numbers, numeric keypad, functions key like F1, F2, F3, F4 till F12, etc. Cursor keys. Okay. Another layout is deliberately designed for easier typing with 2-finger aimed to increase speed and comfort. Okay. For Indian language, the Indic keyboard layout supports 12 scripts. Keyboard touch keys must be sensitive and responsive for the fast typing. Besides physical keyboards, touchscreen keyboard and common now, often with features like predictive text and autocorrect. Scan codes. Each key press sends a unique code to the processor. The keyboard works using interrupt-driven I/O. When a key is pressed, it interrupts and processor to send data. Special keys like caps lock and control send signal that help to processor know their status. When multiple keys are pressed together, this is Control Alt Del, the keyboard sends to make code when a key is pressed and the break code when released, allowing the processor to detect simultaneous keyboard keys. Monitor. A monitor is an output device that shows visual information from the processor on the screen. It helps users interact graphically with the computer both to see output and sometimes give input. Though it looks like a TV, a monitor has better sharpness, faster response, higher refresh rate and clear color than a TV, and also have extra circuits like terminals and monitor don't have. When buying a monitor, Import feature to consider are display size like 14 to 15 up to 24 or more, resolution, how clear the image is, supported frequencies, fresh rates, connector types, how it connects to the computer. Monitor come in flat and curved screen types. There are three main categories of monitor based on the design technology, which we'll explain later. Popular manufacturer includes LG, Samsung, Dell, HP, Lenovo, Sony, Asus, BenQ and others. LCD, liquid crystal display. Simple explanation. LCD were first made in 1960 by a company called RCA. They use special liquids called liquid crystals to show pictures on the screen. LCD don't make their own light, instead they block or let light pass to the create images. They are lights use little electricity and show clear colorful pictures. That's why they are used in laptops and phones. There are three types of LCD based on how they use lights. Reflective LCDs use light that bounces off behind the screen. Backlit LCD have lights shining from behind the screen. EDG light have lights shining from the sides of the screen. Inside the screen, tiny crystal cells are sandwiched between plastic layer. When electricity passes through, these crystals change how light moves, making the image appear. LED, LCD and LED. Okay, that's done with LCD. Continue with LED. Light emitting diode monitor. Easy explanation. LED monitor are flat screen display like LCD monitor, but these are tiny LED lights to light up the screen. The main difference between LCD and LED monitor is type of backlight. LCD monitor use fluorescent light CCFL behind the screen. LED monitors use LED lights for backlighting. LED monitors are lighter, thinner and use less electricity. They give bright, clear picture without flickering. They last longer and shows better color compared to older LCD. What is video card, graphics card? A graphic card is a part of computer that creates and sends image to the monitor so you can see them. How does it work? Think of it like this. Your brain, computer processor, your eyes monitor, and your imagination and memory is a video card. Just like your brain tells eyes what to see using your imagination or memory, a computer processor uses the video card to tell monitor what to show. What are pixels? A pixel is one tiny dot of the image on the screen. Thousands or millions of these tiny dots together make the full picture. More pixels, clear and sharper images, high resolution. What is frame buffer? The frame buffer is like a temporary memory board where the full image is stored before it appears on the screen. The monitor then reads the image from the memory very quickly and shows it line by line. Example. Imagine you are watching a flipbook animation. Each part one frame stored on the frame buffer. Flipping fast, monitor refreshes images quickly. More pages and better drawing, higher resolution and color. The person drawing and flipping pages. Video card. Video card helps create and send pictures to the screen. Pixels are the small dots that make up an image. Frame buffer stores the image temporarily before it appears on the screen. More pixels are colored, need more memory. What is resolution? Resolution means how clear or sharp an image look on your screen. It is measured in pixel. if the resolution is 640 and 480, it means 640 dot pixel left to right and 480 dots top to bottom. More pixels, better and sharper images. What affects sharpness? Sharpness also depends on something called dots per inch. How many dots are packed into 1 inch? Same image on a small screen looks sharper. Image screen on a big screen might look blurry or stressed. So a 15-inch screen may show the image more clearly than a 12-inch screen even with the same resolution. What affects sharpness? Sharpness is also dependent on something called dots per inch. How many dots are packed into an inch? Some image on the small screen looks sharper, some image on a big screen might look blurry or straight. So 15-inch screen may show the image more clearly than 12-inch image even with the same resolution. Real life example, think of photo printed on a paper. If you print the same photo on a small paper, it looks clear. If you print the same photo on a small, it looks clear. If you stretch the same photo onto a bigger poster, it might look blurry. That is how screen size and resolution work together. What is color depth? Color depth, how many color a computer screen can show. It depends on how many bits are used to describe each pixels. Imagine you are painting your colored buttons. If you have only 2 buttons, you can only paint in 2 colors. If you have 4 buttons, you can paint in 4 shades like white, gray, light gray, dark gray, black. If you have 8 buttons, you get 8 colors. So 1 bit per pixel 2 color, 2 bit per pixel 4 color, 3 bit 8 color, 8 bit 256 color, 6 bit a million colors. How it works in screen. Each pixel is built using 3 main colors, red, green and blue. These are called RGB colors. Yes, correct. Every color on the screen is made by mixing these color. Different label, the mixing paints. RGB 1 bit on and off, the 8 color black, red, yellow, white. If each color has 8 bits, you get 256, 256, 256 million colors. The color this is called true color. What's about human eyes? Even through monitors can show millions of colors, our eyes can only see a few millions. So having 24-bit color is really more than enough. It's like having a giant box of crayons, even if you have need a few. Video memory, frame buffer. Video memory is a special memory used to store image or video before they are shown on the screen. The part that holds one full image is called frame buffer. Once again, video memory is a special memory used to store image and video before they are shown on the screen. The part that holds one full image is called frame buffer. How it works? Your screen is made up of tiny dots called pixel. Each pixel needs some memory to store its colors. More pixels, more color, more memory needed. UMA, Unified Memory Architecture. UMA means the main memory is shared with video memory. It makes the computer cheaper but slightly slower for graphics. For a screen of 800 and 600 resolution with 8-bit color, about 480 KB of video, memory is needed. Refresh rate, frame rate. The refresh rate is now many times per second. Your screen updates the image. It measured in hertz. Example 60 hertz equal to 16 per second. The image is refreshed. How it works? A special part called the video controller reads the image from memory. It sends the image to the monitor line by line, left to right, top to bottom. This process repeats very fast to keep the image steady. Two types of horizontal frequency. Two type of frequency. Horizontal frequency, how many lines scanned per second. Vertical frequency, how many full images scanned per second. Why it matters? A high refresh rate, smoother and clear image. Must match your monitor support rates for the best quality. Graphic accelerator. It is a special chip in the video card that help the main processor by handling graphics work. It is like a graphics helper that takes care of making picture, videos, 3D model and games look smooth and fast. Why it's useful? Faster graphics performance, better image quality, supports high resolution videos and 3D, makes gaming and video editing smooth. 3D accelerator, a type of graphic accelerator specially made of 3D graphics. It does math calculation to make 3D images look real on a 3D screen. Help add that lightning and shadows to create 3D effect. Ray tracing follows light ray to create realistic lighting. Jet buffering tracks how far each object is from the screen. Double buffering used to image copies to avoid flickering. When you play games or watch 3D movies, it's the graphic accelerator and 3D accelerator that made everything look smooth and realistic. Video card interface, it is the connection between the video card and the rest of the computer. Help display what you see on the screen, image, video, games, etc. Two types of video card. Onboard video card already built into the motherboard. Separate video card plugged into those special slots of motherboard. Common interface connectors PCI component interconnect made by Intel. PCI a common high-speed slot to connect things like sound card, network card and video card. Modern version PCI Express. AGP accelerated graphic ports, special ports only for video graphics, faster than PCI for graphics. Use smart tricks to pipelining to send data quickly. DMA direct memory access. In some system, video cards can talk directly to RAM to speed up performance. This is called DMA. Real life example in your computer. If your computer is good or gaming and good for gaming or video editing, it's likely has a PCI video card for better graphics. Older PC may have AGP or built-in graphics. एक बार इसको फिर से देखते हैं. वीडियो कार्ड इंटरफेस, इट इज़ द कॉमन कनेक्शन बिटवीन वीडियो कार्ड एंड द रेस्ट ऑफ योर कंप्यूटर. हेल्प्स डिस्प्ले व्हाट you see on the screen, image, videos and games, etc. Two types of video card. Onboard video card already built on the motherboard. Separate video card plug in the special slots on the motherboard. Common interface connector PCI made by Intel, a common high-speed slot to connect things like sound card, network card and video cards. Modern version PCLE, much faster. AGP accelerated graphics port, special port only for video cards, faster. The CPI for graphics, use smart tricks for pipelining. DMA, in some video cards can talk directly to RAM to speed up performance. This is called DMA. Real life example in your computer. If your computer is good for gaming or video editing, it likely has a PCIe video card for better graphics. Older PCs may use AGP built-in graphics. Sound card, audio card. Sound card is a hardware part of computer that help you hear sound through speaker or headphones. Main job of sound card: takes digital sounds from the computer, converts it to analog sound which we can hear, sends it to speaker, also does the reverse, can record sound through a microphone can record sounds through a microphone, converts along voice to digital for a computer. Other feature: amplifies sounds for better volume, mixes sounds for games from games, music, videos, etc. creates new sound synthesis. Type of sound card. Built-in comes with motherboard separate, plugged in an extra part. Important points. Compatibility should work with your software, games, music, apps. Connections should have ports like MIDI for uh, instruments like electric piano. Quality depends on noise level, clarity, and frequency range. When you play a song on your computer, the sound card converts digital sound into real sound you can hear. Digital camera. A digital camera is a device used to take photos or record videos and store them in digital form, not on film like old cameras. How it works? Light from the scenes enters through the lens. It hits a sensor clip like CCD or CMOS. The sensors converts light into digital data. The camera's processor saves the image on the memory card. Keyframes. High resolution means sharper and clear images work as both input and output device. Can show photos and videos instantly. You can edit and print the picture anytime. Very portable and easy to use. Fun fact, the first digital camera was made in 1975 by Steven Sanson at Kodak. Webcam. A webcam is a digital camera without storage that is connected to a computer or network. It can be separate device plugged into the computer or built in inside laptop or monitors. To use it, you need to install special software. It works as an input device by capturing live images or videos and sending them to the computer. Webcams are commonly used for video calls, online meetings, and video conferences on platforms like Google Meet, Zoom, and MS Teams. Voice-based input device. These devices like human voice as input and use speech recognition to understand and act on commands. Unlike a regular microphone, they convert spoken words into machine language and return application accordingly. They recognize speech either from a predefined vocabulary or by learning a specific user voice. Sometimes they ask for confirmation by displaying recognized word on the screen. Example: Siri, Apple's virtual assistants built in Apple devices like iPhone, iPad, Mac, and Apple Watches. You can talk to Siri naturally to open apps and send messages, browse the web, book tickets, and more. Uses artificial intelligence and natural language to understand and respond. Alexa, Amazon's voice assistant. Siri is on Apple's virtual assistants and Alexa is Amazon's voice assistant. Found in EcoSpeaker smart home device and via the Alexa app. Activated by the wake word Alexa, perform tasks like playing music, checking weather, recording mails, and controlling smart devices. Uses AI and cloud services requiring an internet connection. Printers. Printers take text and images from a computer and print them on a paper. They differ by technology, speed, quality, color, and cost. Type of printer: impact printer. Work by physically stripping paper through a ribbon. Make a noise when printing. Two types of printers: character printers prints one character at a time, and the line printer prints a whole line at once, faster and more expensive. Example: dot matrix printer, DMP. Dot matrix printer uses pins to make characters from dots, used for printing tickets, receipts, etc. Non-impact printers print without touching the paper directly, work silently using ink or light-based technology. Two types: the characters printer and the page printer. Again, spray tiny ink drops on paper, print a whole page at once. Sample: inkjet printer, spraying and laser printer use focused light to the print pages quickly and clearly. Laser printer details prints one full page at a time using a laser beam. Uses more memory at high resolution, better quality. Modern one use special tech to make sharp edge and smooth lines. Scanner is an electronic device that captures images from physical objects like photos, paper, poster and slides and convert them into a digital from the save to edit on computer. अच्छा, a scanner is an electronic device that captures image from physical objects like photos, paper, poster and slides and convert them into digital form to save or edit on a computer. How scanners work? They use light sensor arranged in a line to detect the brightness of the image. The sensor scans the source of moving across it or by moving the scanner over the source. Types of scanner. Flatbed scanner has a flat glass surface where you place the image or document. Uses moving sensors to scan high quality and details images. Handheld scanner, portable and small, moved by hand over the document. Cheaper but needs steady hand control for good results. Use the scanners. Scanning checks using MICR, magnetic ink character recognition. Reading barcodes, OCR, optical character recognition. Convert scan printed in text into editable text. Files, helping the digitize old documents. Okay, last but not the least, modems. A modem, demodulator is a device that allows two computers to communicate over telephone lines. It converts digital data from a computer into analog signal to send over phone's line. This is called modulation. It converts digital data from a computer into analog signal to send over phone lines. And next, it is also convert incoming analog signal back to the digital data the computer can understand. This is called demodulation. Modern are used when you connect to the internet and when you receive data from the website. Modems are used when you connect to the internet and when you receive data from the website. Okay, done. So block 2 कंप्लीट हो गया हमारा. नेक्स्ट हम ब्लॉक 3 करेंगे.